Good afternoon, everybody. My name is Rick Bielski, and I'm accompanied by James Jerger and Kevin Zheng, and we created the RFID attendance tracking system. So the problem that many faculty members face today is a good way to take attendance in their courses. And currently, the only method they really have is passing around a pencil and paper. And there are several problems with this method of attendance taking. The first one is that everybody has to sign in, and whether you pass the sheet around or everybody comes up to the front desk at break, some people might miss it, some people might sign in and leave. You might even sign in with your friends and not sign yourself. Also, there's the problem, maybe you can't read the student's handwriting, maybe the paper gets destroyed or misplaced. So there are a lot of possibilities for error in this system. Also, you have to keep records, so that means that you either manually enter this data somewhere after class, or you have to hold on to all those sheets of paper. So there was a past project in the last semester called the ACE box, and that was also an RFID attendance tracking system, but theirs was very limited in that the data was actually stored on an SD card. It had no network connection. The information was stored locally, still providing a way for it to get lost or damaged. It could not display the data in real time. You'll see more on how ours does that in a little bit. And it's very time consuming to get there because you had to take out the SD card and then upload it to your laptop or some other media. So our solution was to create an RFID scanner that will read the student ID and submit it to a database which is in the AWS cloud. The database could then be accessed through a web server, and a web page will be displayed to the professor's either desktop that's in front of him or his tablet or the professor's smartphone, so he could see in real time who is scanning in, the time they're scanning in, and he could go back and see the information later. The attendance information also offers a way to track attendance over time, so advisors and professors could keep track of individual students. And it's all stored in the cloud.
Okay, so you've heard the problem, you've heard the solution. The big question is, why do we want to do this? Well, it's as easy as ABC. First, it's accessible. The entire box is made out of commodity components consisting of an Arduino Uno, which has a network shield connected to it. It has an RFID scanner, which are easy to buy. Most of them cost usually no more than $50, $60. It depends on the quality. The entire thing is compiled using open source code. The code is available. You can modify it to your liking. It's there. It's really easy to use. As said before, the website and the database is stored in the cloud, so it is accessible anywhere you have access to the internet. And the entire thing comes in a small box, which you can take around, say, for like you have an event somewhere in the building, you can just take it and go. It doesn't have to be in a classroom. Next, it's better. It uses unique IDs with the database, which is hard to copy. Many of us might remember the Derrick Rose incident in which he faked his test scores, and Memphis actually ended up having a fine associated with that because he had someone else take his test for him. It's really hard to do it with this system because you'd have to steal their ID to do it. Like said, it's faster than paper because all you have to do is tap it and you're done. It'll show up in the system, and if not, you can add them. The simple box, like said, can be taken anywhere. And the entire system is right in front of you. It's very easy to learn and use. Finally, it's cheaper. Bottom lines mean a lot to all of us, especially in businesses and schools where money kind of runs a whole bunch of our stuff. So to construct a unit, it costs a little under $200. We could compare that to contractors charging us thousands of dollars for systems, like say you have a door lock that your department needs and you have to run it to an invoice, and it would, chances are it'll cost you thousands of dollars as opposed to $200 a unit. So how does this all work? Here we have Kevin.
So we all have, most of us have two types of IDs in our wallets that have RFID tags in them. Our Hawk card is one of them, and another would be a credit card. Our Hawk cards actually use the 125 kilohertz frequency, and credit cards use the 13.56 megahertz spectrum. So you don't have to worry about us stealing your information because we actually can't even read your credit card with this system. So how this works is the credit card, sorry, not the credit card, the Hawk card is read on our scanner and then gets sent through the Arduino. The Arduino interprets that data and then posts it through the web server using PHP. On the Arduino, we have the Ethernet shield, which actually connects and uploads the data through the internet, through our database.
So going off from what he says, we have a SQL server running that stores the information based on the unique codes that are sent through the RFID scanner, and we create tables and view those back to the professor based on this ID. It's hosted online, and it utilizes PHP to communicate between server and database. So, and then finally, we have a web server. This displays information from the database based on the RFID information back to the professor. So how do we put it all together? Maybe a spot of glue and a little bit of duct tape. But in reality, we need a website interface. So our interface will pull the database, and it displays our scan-ins back in real time for the professor to see. It refreshes itself, so as students are scanned in, it'll show the order in which they scan in as well as the time, so you can keep track of who signs in and when. If the student is not found in the database, the professor has the ability to add them as well. Only recognized scans will show up, so it's a good way to tell if someone is or is not registered for your class.
Now we have a quick little video demo, and risking doing a live demo after this.
Plug in Ethernet. Plug in pop.
Plug it in, plug it in.
What you might not have been able to see in that video is when I scanned the ID, my name actually popped up. Should I try it? No, 2 in 1 each. Now we risk a live demo. Redis has already been added to our system, so if we would come up and he would scan his ID, his name pops up at the top. So our web interface is really simple. It has your name. Right now it has a fake student ID number because we don't want to release that to the public. Then you have the time they scanned in. In conclusion, our system, you don't need to use paper with our system. Unique IDs make it really hard to forge because you actually have to seal the other person's ID to actually forge attendance, and it's simple to use for both students and faculty. Moving forward, some features we'd like to implement are absence counter, so we can count how many times a student has been absent. You can see attendance over time, and maybe in the future we implement a photo ID as well. And then we have some people to thank. We'd like to thank Professor Zheng for this, and all the professors that teach ITM 421, 461, 462, and 469. We used knowledge we gained from all these classes to build this project. I'd like to thank the Idea Shop, the Academy, and Mom and Dad. Thank you.
Thank you.